I am the professor. Julius Sumner Miller is my name, and we work and live in this castle and do wondrous things with simple things, such as a metal plate with a tiny hole, tiny weensy hole in the middle. And you remember the question we posed? We put this plate in our oven, and we heat it, and we ask, what doth the plate now do? Does it do nothing? Does it get bigger, or does it get smaller? There is reason to believe that it must do something, so that's out. Now, does it get smaller, or does it get bigger? Most people say the hole gets smaller, which is wrong. The hole gets bigger, and that's wonderful. There are many reasons I could give you for that, but I'll give you one which should be enough. You remember we had the ring, which was a plate with a big hole, and the hole got bigger. Now, is a small hole going to behave in a different way than does a big hole? No, all holes in metal plates, which expand when heated, get bigger. Indeed, I'll put it another way. The hole behaves in the same way it would behave if it was filled with the stuff which is not there. Hey, that's a beautiful thing, isn't it? The hole behaves just as if it was filled with the stuff which is not there. So the hole gets bigger. Now I have another question. You see, it all bears on my first question. Do you understand what happens there when it is heated? Knowing is one thing. To know is one thing. But to understand is quite another. And I cannot condemn you if you do not understand it too well, because it has taken me half a century to understand it. So I'll give you a few years to do better than I have done. Next question. Consider this a perfect circular ring. Notice, if it's circular, it's perfect. The language is redundant, but I want to emphasize its perfection. It is a beautiful circular ring, and it has a diameter of its own stuff. I put it in my oven and heat it. Wait, take it out. Question. Does the ring retain its circularity, or does it warp? Does it retain its circularity, or does it warp? I'm going to tell you for free, out of the kindness of my wounded heart. It retains its circularity, although many of you have already answered that it would warp. Some more on this business of expansion and such. Here is a metal bar made up of two metals brazed along their edge. Iron on one side and brass on the other. I'm going to label this side here so: brass, iron. I'm now going to heat this in the flame. Question, what does it do? Answer, it cannot retain its uniformity in length because the brass has a different coefficient of expansion than does the iron. It has a higher one. Accordingly, it must take the outer side of the curve, and I say this will bend to my left. And aren't some of you hoping and praying that I am wrong? Yes, you evil creatures. I say it bends to my left. Oh, there it is. Give me a small hand, because for once I was right. And thus concludeth our commentary on matters of expansion in metal rods. Question, what would happen if I put this in a bed of ice? Oh, in a bed of ice, you would go the other way, a consequence which you have already encountered. And now we will return in our next program to some further discussion of the push of the air, which we have encountered already with the so-called but wrongly called suction cups. And I shall see you later again.